So, back with some more TIS today. We did, I think, 5 programs, 6. All right, we did 6 programs last time, so we'll get started here with segment 31904, sequence counter. That sounds exciting. Counting sequences. What do we got? All right. Sequences are 0 terminated. Read a sequence from in, write the sum to out.s, write the length to out.l. So we need to sum all of the values and count all of the values and send that forward. But we also need to know if we're done. So interestingly, I'm thinking we want the sum to go straight down and we want the length to go over here. So I'm thinking if we send the number both ways, like all the way down and in, this can handle summing, this can handle counting. And they're 0 terminated, so the first one is 35, 0, and then 62, 51, 81, 54, 12, and 0. Okay, so let's get started. I guess we'll just start move up, down, and we'll move up, down. And then we'll do most of our work here, unless that needs to change. So for the sake of saving, we'll move up into the accumulator, saving a node usage here. And then we'll move the accumulator to the right, and interestingly, we need to track, so we need one in the accumulator and we need one in the backup. So we'll have to figure out how we do that. Maybe we'll start with counting. Counting's a little easier here. So we'll start by reading 1. So we'll move left into the accumulator. All right, and then what is our jump? I think it's JNZ, right? Or LZ. Let me pull up my commands here. Coming through. It's hard to turn these pages for some reason. All right, we got no ops, comments. Who needs comments, right? Jump equals zeros, JEZ, JNZ, JGZ, JLZ, and then JRO. Transfer execution unconditionally the instruction at the offset specified by source. Okay, we'll leave that open for now. Let's see what we got here. So if we're equal to 0, we're going to out the length. And when we're out, we're going to swap. I'm pretty sure it's WSP. Moving away from the mic here. WSP, the values of ACC and back are swapped. That's correct. And then we're going to move ACC down. And then we can go back to the start. So here we'll just jump to the start. And for now, we'll just tag that start. We need to swap them because we need to increment. So if the accumulator is not equal to 0, we want to not have that be start. Our starting should be, or we'll call it like new, I guess. And we'll put 0, move 0 into ACC, and then we'll swap. And then this will be our loop here, so we'll just call it L. And then you will jump to the loop, and then I'll go back to the new. We don't really need a label there, I don't think. So if we're not equal to 0, we want to swap and add 1 and swap and then jump. So that should count correctly. So if we just step through that, we should get, I deadlocked us immediately. Okay, so we should get 35 going down, it goes in here, then it sends over here, that moves it into the accumulator. It is not equal to 0, so it swaps, adds 1, swaps, jumps back to the loop, and then by then it moves 0 into the accumulator, where we swap and we write 1, which is the expected value for the first sequence. Okay, so now we need the sum here. We're going to need a similar pattern. We want to start by doing that, kind of initializing our state for each sequence, and then we're going to start our loop where we move up into the accumulator, and interestingly, I'm going to have to get the value back. So what I'm probably going to do is just to save nodes, to save on nodes, we'll just move it twice, which means we need to move it into the accumulator here, and then we'll move the accumulator down twice. So this will read it once to move it over, and yeah, it'll read it once to move it over. So we'll move the accumulator to the right, and then we will, let's jump in. So we've got it in the accumulator, we've got the sum here, so we need to jump of 0, we're going to output, and we're going to have our out again, which is going to swap, move accumulator down, and then that'll start back over. And then if it's not 0, we need to jump back to loop. But before that, we want to swap, and we want to add, I think we just want to move accumulator. What is it? Null, right? Don't we have like some kind of empty right? I think like a register where we can just delete values. No, yeah, nil. Yeah, we can move it to nil. So we want to move up to nil. We may not need that. I'll come back to that in a sec on why I added that. I'm working on like 3 different things in my head at the moment. Let's see. Okay, so we want to, if we're done with the sequence or not done with the sequence, we need to swap so we can add up, and that'll move that to the accumulator, and then we can swap that back. We can actually get rid of that swap if we put our loop start right there, that swap, and we can probably do the same thing over here because we're swapping before we jump. So if we put our loop right there where we swap, okay. I don't think I need that. I think I was thinking there might be an extra value. Yeah, there will be an extra value because we're writing down twice, and we're only reading twice if we're adding. So we need to account for that second read when we're done. So this should work. Let's see, 35 comes down once, gets sent to the accumulator, it gets sent over here, and it comes here where we're swapping to our 0 here, we're adding up, and then we jump back here, we swap again, we've got 0 coming in. 0 goes over here. And we have our sum and our length there. They both jump to swap at the same time. This moves the accumulator down. This moves the accumulator down. And we move up into nil, which is that extra 0 that we just eat. Next, we've got 62 coming in. And we've got a new length. So we've got 0 in both accumulators. We got 1, we bring in 51, we got 62 and back up, we got 51 here, so we swap, we add. We've got a length of 2. Our sum and our length are back in storage. We've got 81 coming in, and then 54, and then 12 comes down for the first time. So that gets sent over here. We can see we're at a length of 4 right now, a sum of 248, 260. Finally, we get a 0. And we write out 260 and 5, which is indeed the expected values. We did it. Our cycle count is kind of mid. Our node count is good, and our instruction count is a little below mid. I'm okay with that, but I want to go back and take a look at this here. I've already forgotten the other ones, but we'll figure it out later. I just want to look at it. Let's see. No, she won't understand. Of course she doesn't. Why would you expect her to? Just keep working. I feel like I'm learning about the people behind this and their design decisions, the thoughts that went into figuring out how things should work. For $1, those people feel very close to me now. Lie. Okay. Interesting. I'm not sure what to take from that right now. So we'll... Ooh, no. Let's... Whoopsie. Let's not do that. Okay, we'll move on to the next one. Yeah, you can see I kind of done this before. Signal edge detector. We'll jump in there. Next. Read a value from in up here. Compare value to previous value. Write 1 if changed by 10 or more. If not true, write 0 instead. The first output is always 0. Okay, interesting. So we're going to read in a value, and we need to know if it differs by more than 10 of its original. So this is going to be a little bit challenging because we don't really have a way to compare arbitrary numbers. We can only compare to 0 and directions from 0. So the first thought is we'll move where's out's over here. It doesn't really matter where logic is going to go in the nodes, but we do need some comparisons, so I think we're going to have to store values in multiple nodes, because we'll basically have to put the previous value in a node and then get it back. So I'm trying to think through what I want to do here. I think the first thing is just to read in 2 numbers and try to figure out how to do the math first. So let's do that. Let's get the accumulator in, and then we're going to move the accumulator. I don't know, for now we'll just move it right because we're going to go that direction anyways. And then we're going to move, so that's the previous value now, and then over here we'll move the left value left. So basically just circle that back. We're not worried about output. This program's not going to function correctly. We're working on the math. And then we want to bring in the value here. So we want to move. Do we want to move? We've got the previous value in the accumulator, and we've got the previous value stored. Well, that's the first value, which is technically the previous. So now we can sub, oh, but we don't want to lose this one. Yeah, we need both of them. Let's swap. We can save. Doesn't really matter, really. Let's swap. And then we can move up into the accumulator. And shoot, I'm getting stuck here. Okay, let's just let's move the accumulator down, and we'll do the same thing here. We'll move up. So we'll cycle that back. So we've got both of the numbers pending. We've got the first number over here, second number over here. We'll change that up in a minute. So we want to swap back. So we have our first number in accumulator. And then we need to subtract the second number. So let's just do that. Let's sub down and see where we're at. So if I do, let's step in where we're at. Okay, so we've got 0. We bring in 32. I've got 0 over here. I should write 32 down. And then I bring 0 back up here. And negative 32. Now we want to know if it's 10 or more. 10 or more. So I guess the question will be, oops, why am I looking at the book? The instructions are not in the book, they're up here. Compare to the previous value. Write one if changed by 10 or more. So it doesn't specify a direction. So it sounds like we probably want to negate it if it's negative. So we know this one's negative, this first set, so we could just go ahead and negate it already. Make sure our math is working. We get there. So now we're positive 32. And now we want to sub 10 probably. If I'm thinking correctly, I want to sub 10 from that. Where am I going with this? We're going to take 10 off, so we're at 22. And then theoretically, if that is positive, then it's a 1. I don't think I need 0. I only need the last number. So we can probably get rid of that extra right there. Yeah. And then I think I'm just going to switch to save. It's basically the same thing, but this just means put the accumulator in back. And then we write so that gives us 22, which is greater than 0. So that's a 1. And then we bring in, oh, we're not taking the last value. So where is our last value going? This note's not in use. So we have the last value in our backup. What are we doing with it, right? We've got it there. So now we want to persist that last value. That's going to be, it's already in backup. So we read 30 in. Oh, we lose it. We lose it. Because of that. Yeah, I think we want to swap instead of save. We want to keep that old value. Right, so we've got 30 in. But now we have a problem. So we've got 0 is going to be our first number. It's kind of guaranteed. We have to seed the process. And then, so there's going to be an initial step. Like the first thing we'll do is set up, and then we'll do like a loop here. And we can jump to the loop. And then our initial setup will be to move up into accumulator and probably swap like that. Actually, it works without the parenthesis, yeah. Okay. Okay, so we get 32 in. We subtract What's going on? Wait. We bring in 0. We swap, and then we bring in 32. And now we need to subtract 32 from 0. So at this point, we're going to do our move up, down, and then that's going to go up, up. Then we can swap then we can swap and we can sub down. Let's get rid of this and then sub 10. We'll figure out where we get that next value from. So 32, and then, wait, where's 0? We're losing 0. Okay, so we put 0 in the accumulator, then we swap. That's like a no-op, basically. And then we move up into the accumulator. And then we move up, down. No, we don't move up, down. We move the accumulator down. Okay. Now we have our first value and our second value. And now we have our new, like, previous value. It will be the previous value, but this is currently the previous value. So then we sub that, and we subtract 10. We should probably negate it first. We'll figure the logic out of that one later. Right? So we want the absolute value. I don't think there's a way to do absolute value without implementing it ourselves. Yeah, there's no way to do absolute value without implementing it ourselves, which is fine. We're just kind of faking it right now. And then we subtract 10. Now we're going to do if it's greater than 0. Because like if it was 9 minus 10 should be -1, so it won't be greater than 0. So if it's less than 0, we want to move what is it, a 0? Right, 1 if it changed by 10 or more. So at this point, if we're less than 0, then we're, if not true, we're going to write 0. So we're going to move 1 left. That's right. I can't get my directions right. Okay, right. And then we're going to move left, down, move up, down, move up, down. Okay. And then what do we've got here? We need 0. So 0 will move 0 left, right, and then we'll jump now. Yeah, so that looks good. That looks good. I don't really like the 2 jumps, but we'll deal with that later. I'm gonna go ahead and turn this into absolute value. So we'll move. What direction is that? Right into accumulator. If it's less than 0, we'll negate it, and then we'll just like that, and then we'll move. We'll call this right. We'll move accumulator back to the right. So this will be like its own little function, so to speak. And if it's not less than 0, we'll just jump to right. And then here, instead of negate, we'll move accumulator to the left, and then we'll move left into the accumulator. Then we can sub 10, and we can do our logic. So let's see what we got. We got 0 coming in, 0 coming in. By the way, we should do move 0 down. We're just going to kind of hack this, and then we'll do that, and then we'll jump to try and keep that first value kind of out. And okay, so we move 0 down because the first output is always 0. And then we read in our 32. We subtract down. We move it over. It does our absolute value. We get it back. We subtract 10. It's not less than 0, so we move 1. And then we start over. We pull in 30. We write it down. We swap, so we have 32, which was our last value that we read. And we subtract. We move that over there. That writes us 2 back. We subtract 10. That was less than 0. So that was 0. That was... We did it! Our cycle count is garbage. Even worse than my first attempt at this. Node statistics are a little more than average, and our instruction count is deeply in the mid here. Yeah, I'm not really happy with this. To be honest with you, I'd like to know what I did originally, but I've already deleted those. So let's see what we've got. We've got a lot going on here. For example, like we have an extra node that we probably don't need. Like we could repurpose one of these nodes really. Do we need this, right? What are we doing with it? We move up into the accumulator. We've got the previous value. We subtract that. We negate it. We absolute value it. And then we do our test. Then what do we do here? We're moving. I'm not seeing it immediately. I'm not seeing a way to improve. I'm sure there is. Let's see. And then we subtract 10. This subtract 10 step. It's got to be somewhere. We could probably offload this work here. Like we've got an absolute value node, and we've got 2 nodes that are doing absolutely nothing. So what I'm thinking is we could, at this point in the program, we could just move the accumulator to the right? And then over here, we're gonna change right to left, and then we'll negate it. We don't want to call that work anymore. We'll sub 10 from it at this point, right? We'll process it. Process. And then we can move the accumulator down. And then here, what we can do is we can do our tests, right? So we have, if it's less than 0, we're going to move up into accumulator. If it's less than 0, we're going to write out 0. So we'll move 0 down. Sorry, that's 0. And here we'll move 1 down. And then we'll jump back to our start point. I'm calling it loop, so we'll just stick with that. Okay, we still have our free move 1 down. Now we can do less here. Once we subtract the old value, we can just move on. So, okay, so we pull in 0, we pull in 32, we swap, we subtract that 32, and then we move negative 32 right. It does absolute value on it. It subtracts, it pushes 22 down. 22 runs through. It pushes, what did it push down? 1 down. Yeah, so that worked. Now we have this spare node that's just repeating an input. And it does that while this is waiting. So what we could do is we could make this one what am I thinking? We're going to move the left node left again. So we're going to repeat it. And then here where we move down, we're going to sub right. And we move it down. So that's always going to repeat once. And then it's going to process. And then it'll repeat. Okay, we can run that. Oh, we got some invalid. What do we got? We got an invalid. Where are we at? Here at 28. Okay, so what's going on when we get to 28? Okay. What is going on with our output here? So I want to watch. All right, 22 is coming here. We move 1 down, and we jump back to loop, and then we wait. Then we get negative 7. What is negative 7? It should be. Okay, where's negative 7 coming from? Let's watch our first node. We've got 32, and 0 minus 32 is negative 32. We've got 30. Whoa, we've lost 32 completely. What's going on? We're missing our jump back to the loop here. Okay, I think that's what we were doing. And then that should keep the 30. Yeah, there we go. And then we've got 2 minus 10. 8 comes down. There we go. Okay, so our cycle counts are down quite a bit. I think it was 600 last time. So we're like, at least we're better than I did originally. Our instruction count is still pretty high. Our node count is down now. I'm a lot happier with this. I wonder, what can we eliminate instruction-wise? We do. I mean, if we don't negate, we could sub negative 10 or sub 10. What is that? That's not going to change anything though. But then we have to change our test here. We're dead more code. I think I'm happy with it. What do we have here? And days and days, cycles and cycles, and 56 just one after another. I'm sick and tired. People who don't respect me. Okay. All right, let's go back to our list. Where are we at now? Boom, moving on here. We've got some old stats to beat. Can we do it? Probably. We'll see. Interpret handler. interrupt handler. I can't read. Hello. Okay, interrupt handler. Read from n.1 here through n.4. So all 4 of these are inputs. Write the input number when the value goes from 0 to 1. And 2 interrupts will never change in the same input cycle. 2 interrupts. Write the input number when the value goes from 0 to 1. Okay, so the output here, they're all 0, so we output 0. They're all 0, so we output 0. And this one, it's 4, so we output 4. And this one, it's 3 and 4, and we output 3. So it looks like it's a first come, first serve basis. So what I think we need to do is kind of funnel the values in. So what we'll do is we'll move up to the right, and we'll move the left down. Is it down here? Yeah, I'm gonna do it down here just because, and then we'll move up, down, and then over here we can move up straight down, and then over here we'll move up to the left, and then over here we can move right down. Now I've done it this way for a specific reason. So the input 1, we move that right, and then we move that down. So that's 1, and then we move 2 down. And then here we move 3 down, which is the up down, and then we move right down, which is 4. So we have 1, 2, 3, 4 coming in. So here we're going to move up to the right, move up to the right, and then here, well, actually we already have that one. We don't need another node there. All right, so we've got 1, 2, 3, 4 coming in here. So now we just need to track which one is which. So what we need to do is we're going to, per unit, we'll set a, we'll move 0 into accumulator, and we will save that. We'll swap, and then we'll move up into the accumulator, and we want to do this 4 times. So we'll figure out how to do that. We want this to be like a loop start. Move up into the accumulator. No, that's going to happen twice. I think these are fixed right now, so we don't. I was thinking we're going to add it up. We'll just do this. Move up into the accumulator. If it's not equal to 0, JNZ, I think. Pretty sure I should just leave it on the jump page, shouldn't I? Equal, yeah, not equal to 0. Instruction after the label will be executed next if the value accumulator is not 0. Okay. So if it's not 0, we're going to print 1. We'll add that later. If it is 0, we'll move up. We don't want to move up. We need to move from the left here, right? And then we're moving left again into the accumulator. If that one is 0, we'll move 2. I mean, if that one is not 0, we'll move 2. And then we'll move up into the accumulator. That's 3. Move up into the accumulator. That's 4. Otherwise, we'll move 0 down. J and Z 4, right? Okay, and then here we'll just jump. Start. And we'll start here. Just like that. Okay, so now we need 1, Move one down. We're obviously running out of nodes here, so that's great. We'll move one down. 2, move 2 down, 3, move 3 down, and 4, move 4 down. Actually, I'm wondering if we just do it in the node, right? If this is, if we move that in the accumulator, and it's 0, if it's not 0, we move 1 down. And then if it is 0, we move 0 down. And then here we can put 1, jump back to the start. Keep it consistent, and we'll move 1 down. Or not down, we're not going down, we're going, you know what, I'll send it down, that's fine, and we'll do that. And then for the others, we'll basically copy the same logic here, except we're gonna correct down in all of them, and we're moving, maybe we'll call it on instead of 1, and we'll copy all of it this time. There we go. Okay, we'll replace all of that. Now we got these numbers. This is gonna send 4. This is gonna send 3. This is gonna send 2. Okay, we're using every node, which I know is gonna be bad. We'll fix it, maybe. We'll see how it goes. And then we can do a little bit of logical processing on some of these nodes. So we'll move up to the left, and here we'll move up, right, left, right, and then we'll move up, right. Okay, and then here we'll basically do the same thing. So we'll move in the orders that we're in. We'll move from the right, from the left here. We'll move left into accumulator, J and 0, right. Right, and we'll move left into the accumulator, J and 0, right. And we'll move up into the accumulator, J and 0, right. And we'll move down, right into the accumulator, J and 0, right. And then here we'll move 0 down, and we'll jump loop. And for right, we'll move accumulator down, and then we'll put our loop back here. Okay, so this one will write 1 down, this one will write 2 down, this one will write 3 down, this one will write 4 down. But that's if it's changed from a 0 to a 1, right? So this 3 was a 0, now it's a 1. Boom. It didn't change here, so it doesn't write out. So this is going to be wrong. We have a deadlock. Whoops. Oh, yeah, we have a deadlock because you need to move up, down, just like that. Okay. So, boom. All right, yeah, we got all the wrong values because we need more logic in each of these. So, what do we do? Only if write the input number when the value goes from 0 to 1. So it's like it needs to mode switch, really, right? So we move up into the accumulator, and jump not 0 goes to on, which will move 1 down. But then on loop needs to do something, which is basically move up into the accumulator and jump when it's equal to 0 to loop. Otherwise it jumps to on loop. And then here it just moves 0 down. So if that's right, then it reads in 0, it reads in 0, it reads in 0, it reads in 0, where's 1? Okay. So here it reads in 1. So we read in 1 now. Okay. So now it moves 1 down, and then it moves into the accumulator until it reads a 0 again, then it resets. Yeah. Okay, so we've got this pattern that seems to be working. So now you just need to move 2, move 3, and move 4. Okay, so now we still have a problem. What do we got? Okay, we need to follow. We got 0, 0, 0, 0. And so they all move 0 down. So now we have 0, 0, 0, 0. This 0 goes right. That 0 goes right. Then this upper 0 goes right. Here we are. We've moved 0 in here. If we're not 0, we write it. We move 0 down and we start over. And at this point, let's go back where we've got all of our zeros going down. Why are they not? Oh, yeah, okay. So we've got a phase switch coming in on 4. So 1 comes in, it turns on, it moves 4 down. Then we wait for 4 to get red. You know what? If we jump to right up here, we're kind of ignoring values. That's what's going on. Yeah. Yeah, this is not ideal. So we need to split this logic up, I think, right? So if we move this here, then we can actually, here we can just move left into the accumulator, right? We're going to discard some values here. So if it's not 0, then we're going to go with 1, right? And so if we go with 1, we're going to move accumulator to the right, and we're going to move up into nil. So we're going to eat number 2 because it doesn't matter. One was turned on. Otherwise, we're going to move up to the left, to the right, to the right. And then we'll jump back to our loop. And we'll put loop here, okay. And then over here, we're kind of doing the same thing, but with, so we have 3 up top. So we're going to move up into the accumulator, and if it is not 0, we're going to move to 3. 3 here. Actually, we need to read 2 first. So we need to move left into the accumulator, and then if that's not 0, we're going to write 2. Now, if 2 is written, we're going to move the accumulator down. We're going to move up into nil, and we're going to move the left into nil, because we're going to eat 3 and 4. So those get eaten. If it's not 2, we're going to move up into accumulator, and we'll jump to 3. And then finally, we'll move. We can just literally take 4. So we'll move the left value, the right value down if it's not 3. And then we'll jump loop. We'll jump loop here, and we'll put 3 here. So we'll move the accumulator down. So let's call it tree. Move accumulator down, and then we will move. What are you, right? Right? Why can't I get it right? Right to nil, and then we'll jump. No, we don't need to jump there. Okay. Okay, that should do it. So now we're writing our values down. We're getting the wrong value here. Why did we get a 3? Okay, let's follow the logic. So we know 3 is going to be wrong. 3 reads in a 0. 3 reads in a 0. 3 reads in a 1. It's on, it moves 3 down. Actually, let's follow the first set of zeros. Okay, so we've got.
Whose contact info are you looking for?
Oh, I don't need your help, Siri, unless you can debug this. All right, where are we at? Okay, let's start back over. Okay, so we've got 0 coming in from the first node. We've got 0 coming in from the second node, and we want to move the left value here into the accumulator. So that's what we do. And then if it's not 0, we jump to 1. So now we move up to the right. So that moves that 0, and we jump back to the start. And we move left into the accumulator. That's going to be 2 or 1, whichever one comes in. So we're now testing 3. It's 0. We're now testing 4. It's 0. We start over. So now we move the left value into the accumulator again. Move left here, move up right. Okay. So then we're back down. They're all 0. Okay. We're back at the top. So we've got 0 from 1 and 2. We've got 0 from 3. And we've got, we wrote 4 out. At this point, we do expect a 3 to come through, so let's see where we're at. We've got 3, so that jumps to 3, which moves the accumulator down, which is 0. And then we move the right value to nil. we expect another 0. Why do we not have a value to the right? So that's the problem. And then the next time, that's moving up to the left, right? And we're moving 4 down. So that should, I mean, all these should go straight down. What is happening to the value here? We've got 0, 0, 4, I see. We're not consistently writing. Okay. So on this loop, if it's equal to 0, we start back over. But basically, we need to move 0 down. So like 0 needs to go down when we're on, because it's already flipped. So we need to be writing 0 down the whole time it's on. So once node comes on, it should be writing 0s down. Of course it's not. I didn't copy this. Son of a gun. Okay, this goes back over here. Oh man, we'll change this stuff. I know I typoed that there. That's gonna be a 3. Okay. Yeah, now we're writing 0. We write 0. We write 0. Okay, so now we're still getting the wrong values. Goodness gracious. Why was 2 written? 2 should not have been written. 1, 2, 3, 4. Okay, they all have the right numbers. They all move 0 down while they're on. I got 0, 0, 0, 0. Okay, so we've got 0 in from 1 and 2. 3 is 0. 4 is 0, so it just moves 0 down. Then we've got another 0 coming in from 1 and 2. 0 from 3, 0 from 4, so it moves 0 down. This is when we get 4 from 4, so everything is 3. We move that down. Okay, we've got 0 from 1 and 2, which is correct. 0 from 1 and 2. That went from 0 to 1, so we should have a 3. That went from 1 to 1, so we should have a 0. So we have 3 from here. And so we move to 3, where we move the accumulator down, so that pushes 3 down. And then it moves this 0 into nil. And we're back here. We've got 0 from 1 and 2, 0 from 3. So we move 0 down. Then what do we have? We've got 0 from 1 and 2. Two is going to switch on the next frame for it. We've got 0 from 3, 0 from 4, so we write 0 down. We've got 1 did turn on this round. 4 is still on, so we've got 1 written in. So that jumps 2, so that writes 1 down. And then it moves 3 into nil. And left into nil. Okay, you need to move right into nil. Okay, there we go. That's what I'm talking about. Okay, we're actually not quite as bad as I thought. I think we're probably where I was earlier. Yeah, like 9 nodes. Yeah, this is pretty nasty. I'm not sure where cleanup's going to happen. It's a little bit complicated, and I'm not seeing it in this instruction set exactly how we would do it more easily. Like, I'm thinking, some of the other electronic games have a little bit, I guess, fancier logic that I might use, like swizzling, so we could put all of the numbers into one. I mean, technically, we probably could. Can we put 1,000 into a node, just out of curiosity? Can I move 1,000 into accumulator? Like, is that valid? Yeah, so it only holds 999. So we couldn't store 4 values anyways. So there's not really a way of encoding it. We could encode it as a 2-digit number, but that all feels like a lot more effort than what we have already. So I think I'm just going to leave it. This was a pretty complicated challenge too. All right, let's I didn't do this thing here. What, my sister was over for the holidays, I think, to check on me, make sure I haven't gone off the deep end. I know I caused some worry. Her kids saw me working here, and I suggested I could surf the web for TIS-100 specs. So even kids are on about internet online, blah, blah, blah. It's a racket. I don't care about the information superhighway, and I never will. Interesting. Let's see. What are we doing next here? Good. Exit this way. Okay. This is a user segment, simple sandbox. So this just kind of lets us do what we want. Yeah, this just gives us free reign to do whatever. I don't have an idea. I mean, I don't have anybody in chat, so I mean, if you are in chat and you want to send an idea, please feel free to do so. Otherwise, I'll move on and revisit that if I get an idea. Signal pattern detector. So again, I did this one before. I'm going to write these stats down so we can see. I don't have a pen. I don't have a pen anywhere. What use is a desk without a pen? Well, I have a computer. Who needs a pen when you have a computer, right? Let's see. We'll pop open a notepad here, and we'll put in, what were those numbers again? 394, 5, and 17. 394, 5, and 17. Okay, cool. We've got the numbers that we need. Let's jump in and see what we got. Okay, read a value from input here. Look for the pattern 0, 0, 0. Write 1 when pattern is found. If not true, write 0 instead. So we've got 2, so that's obviously a 0. The first 3 zeros, the first 3 outputs are going to be 0, always, basically. But we'll have to pre-code that in some way. But yeah, so we've got 2, that's a 0. We've got 0, that's a 0. We got 0, that's a 0. We have 2 zeros now. So we read that 3, that kind of breaks the pattern. 4 is a 0. We got a 0, 0. That's the third 0. We have a 0 here, so we add, so we're good there. We've got a 0 there, so we're good there. So I'm thinking another, probably phase switch, kind of. So we don't have 3 values yet, so initially we're just going to have to move 0. Where out is over here, so we'll move this way. So we'll move 0 to the right, and we'll move left down, move up down, and we'll move up down. Now you might notice that I always tend to start putting logic in this first node. I don't know that there's any benefit to that. Maybe it's the wrong way to do it. I don't think it really matters. Like, you could put all the logic here, you could put all the logic here and go this way. Like, that's still 4 nodes, 1, 2, 3, 4. You know, the shortest path to this output node is 4 nodes. So the first thing I do is like establish a path, and then I just start writing logic in the first node. And if I need to distribute logic, that's when I'll start to do it. Anyway, so we'll move 0 right again, because the first 2 have to be 0 always. So this 2 here is going to kind of line up with this 0. These have to be 0. And we'll that should, I mean, that's probably not going to work anyways. Right. See, okay. Something's got to keep the sequence. We need like a state node, right? So like one of these should be a state node, and then maybe this one just reads to it. Because it is 1-to-1 on the output. So we just need to be false on the first 2. So where are we gonna store the state? How are we gonna store the state? Let's put the state here. Why not? Okay, so we're gonna move the accumulator into this will be our like initial. So I guess we'll just do like, can we do numbered? Oh, cool. Like numbered labels, that works. Okay, so we have our like initial 0 state. We're gonna move the left into the accumulator, and then if that's 0, we want to go to state 1, right? So we need a state 1, and then kind of in state 1, we're going to move left into the accumulator, and we're going to jump equals 0, 1. I'm wondering if this would be a good time to use our, what is it, JRO? Let's see, the previous instruction will be executed next. The next instruction will be skipped. So that would be nice, because then we wouldn't have to like have all of these. We'll see if we can work that in a little bit later. Okay, so if we're in, we want to move to state 2, right? And then here in state 2, we move left into the accumulator. This is the point where we've seen 2 zeros already. So if it's equal to 0, we're gonna move. I guess we'll just do 1, and we'll do 1 is move 1 down, and we'll jump back to 2. Right, we'll jump back to 2. Let's call this true, just to signify that this is like the true one. And if it's true, we're going to jump back to 2. If it's not equal to 0, then we're going to jump back to kind of our we'll jump to false. And false will be move 0 down, and it will go all the way back to, and so we can just jump false and jump false. Jump false right there, yeah, okay. So theoretically, if we just move up right, that should do it. Let's see. So we read in 2, 2 goes there, 2 is not equal to 0, we write 0, we're back to 0. 0 is equal to 0, but we need to write, See, this is where we need like 1S, right? We want to jump to 1S, and 1S kind of starts the one segment, and it's going to move 0 down, right? And then that's jump to 2S. 2S is going to move 0 down, right? And so when we're jumping between those two stages, that writes our 0. Okay, so now we jump false, that moves 0. We have 0 now, so we jump to 1. That moves left into the accumulator, which is 0, so we jump there, we move 0 down. And we've got a 3 coming in, so that's false, which starts us back over. That's false, that starts us back over. We've got another 0 in. We've got a 1 coming in. Now, another thing that we could do is we only care about 3 zeros, right? So if we accumulate how many zeros we've seen in a row, then we can write that number down here every time, and we can avoid passing numbers around. So that might be another option. That worked. Actually, where are we at? We were 394 was the original implementation, and this is at, what was that? 188 cycles, so that's a significant improvement there. We're one node better. We have the same instruction count. Okay, so I had another idea that I wanted to do, so let's return to the segment list and let's go ahead and start a new program, because I want to show off this idea, see if it's any better. All right, so the idea here is we're just going to move. We're going to do the same thing we did last time, basically, or we're going to start the same way we did last time. We're going to move up to the right, so we're going to get the number in this node. Once we're here, though, instead of all of that state keeping, we're gonna init. So we'll just call it init. We're going to move 0 into the accumulator. That's like a no op right now because we already have 0 in the accumulator, but it won't stay in the accumulator. Now we will swap. So we're going to move. This will be where our loop starts, by the way. We're going to swap to put the back. I guess we need to move, and then we'll save that down into back. So they're both zeroed out. No, I don't think that matters, right? We'll swap, and then we're going to move the I think I have an idea. No. Yeah. Because we're gonna. Okay, so what's gonna happen is we're gonna end up where we move the accumulator down here, and so the accumulator will be our count at that point. And so if we start off save, we're gonna move the new accumulated value into back. Then we don't have to like swap. I think that'll save maybe some operations. We'll see. Maybe it doesn't. I mean, there's no code written, so it's hard to tell right now. But let's see. Okay, so we're gonna move now. We're gonna move the left value into the accumulator, and if it's 0, we're gonna increment. Otherwise, we're gonna init. We'll just jump back to, or we'll jump to 0. We'll jump to false. All right, so false is gonna move 0 down, and it'll go back to init. And then increment here. Increment will swap, add 1, move accumulator down, and then jump to loop. And then in here, we're going to move up into the accumulator, sub 3, jump if 0, true, Otherwise, we're going to move 0 down. And jump to loop. And then on true, we're going to move 1 down. And we'll have this be our loop start. So we kind of split our logic up a little bit. And then here, we're going to move up, down. We're not going to do anything. So theoretically, we've seen 0. All right, so we've got a 2 that comes in. We move 0 down. We reset. We've seen a 0. We increment. Wait a second. I just increment, add 1. Oh, yeah, it moves it down. Okay, so now we see a 0. So we increment. We move the accumulator down. So we move 1 down here. And that's still not equal to 0. So we move 0 down. Then we swap. We add 1 because we've seen another 0. So now we've seen 2 zeros. We see a 3, so that's false. That moves 0 down. And we start. You know what? I think we can actually get rid of this up here. Because that will happen here on false. We can move 0 into the accumulator. And then we can move. These both need to move the accumulator down. So we can actually. Let's see. We'll do that. That's fine. Move the accumulator down. And then that'll go back up. Okay. So, all right. So we got a 2 coming in. That jumps to false. That writes 0. And that moves the accumulator down. We save 0. We see a 0 this time coming in. So we increment. And we write 1 down. And then we see another 0. So we increment. And we've seen 2 zeros in a row. And we move that down. Now we've seen a 3. This is a 3. So we're going to go to false. And we're going to overwrite 0. Because we've seen 0 zeros now. I just realized there's a bug. So we're going to get to the point here where we should output 1. So our increment is 3. That outputs a 1. That outputs a 1. Yeah, now we're getting that because it's no longer equal to 0. So what we need to do is actually really simple. We'll just change E to G because if it's greater than or equal to 3, that's what we want. So yeah, so we'll run that. That'll get us 1. Okay, now we're here. We've seen the 4. We've seen 1 0. We've seen 2 zeros. We've seen 3 zeros. And what is going on? Okay, sorry. Let's walk through that again. We see the 3. Why have we written only 2 out? Okay, we must be missing output. Okay, so we move 2 in. 2 jumps to increment, which moves 0 into the accumulator and moves 0 down. That gets subtracted. And there. Okay. Now we move 1 down. Which should write a 0 down. Jump is 0, increment. So we see the 3 now. So that resets us back to 0. We move the accumulator down. We increment, we move down. I wonder. So this is going to be 0, 0, right. It's hard to keep track here. Where are we at? Okay, so we've got 2. We've got 0. We've got 0. We see 3 coming in. Three rights, 0 down. 4 rights, 0 down. 0 comes in. It's our first 0. That's our second 0. That's our third 0. So we write 3 down. Oh, we have another bug. Greater than is not greater than or equal to. We need actually both of those conditions at the same time. That does it. Okay, yeah, so that's worse actually. If we return to the segment list, we can compare. So the kind of hard-coded approach that we did here with the where we hard-code each of the states based on the number of zeros that we've seen, that's actually more performant. We kind of unrolled the kind of looping that we're doing. So it speeds it up, the cycles up a little bit because we're doing a little less processing. We're doing all this like increment. We could probably optimize this a little bit, but yeah, I think I'm happy that we were able to demonstrate that. Okay, where are we at now? We've got this next one. Where's the first one that I haven't completed? Ooh, wow. Yeah, that one takes a lot of cycles. Okay. Right here. Did I didn't do all. Yeah, okay. So this is the first segment that I haven't finished yet. Before, like I said, I've restarted. It's been a while. Okay, let's see what we got here. Let's compare to my original. What are we at? 496. This time 9 and 72. And sequence peak detector. Okay. Sequences are 0 terminated. Read a sequence from in. Write the minimum value to out.i. Write the maximum value to out.a. Okay, I think I remember this one. So basically, for each value in the sequence, I'm going to write them to both of these nodes. And then one of them will be min, one of them will be max, and then we'll just move. So these are going to be the dumbest nodes down here. They're going to move up, down. Can I? Yeah, there we go. Move up, down, right? So we got up here, our initial, we're going to move up into the accumulator, so we can move the accumulator down, move the accumulator to the right. And then we're going to move left down, and then over here. What is out.i is the minimum value of the sequence. So we're going to move up into the accumulator. You should always start with a loop label. And then if it's 0, then we're done. And when we're done, we're going to swap and we're going to move accumulator down. So that'll be the minimum value. And then that'll start over. If we're not done, we need to hit the loop again. If we're not done, let's just put some space there. If we're not done, we need to find the minimum value. So, yeah. So I need to see the number twice. So I want to move the accumulator down. So that's going to save it. We're going to swap to bring our minimum. Our minimum is going to be here at this point. we're going to bring our minimum up, and we're going to save it. So we put it back, and now we have it in accumulator. Then we're going to sub down. Now, if the down value is equal to the accumulator, it'll be 0. If the down value is less than the accumulator, it'll be greater than 0. So if it's greater than 0, we want to store it. And I'll put store down here. We'll move down into the accumulator. We'll just call it str. I know that stands for string, but disk save, I guess. We'll move down in the accumulator. Let's save that, and yeah. Okay. Oh yeah, we changed the name of that to save. Running out of instructions here, so I might have to do this. Well, we'll see what has to happen. Like if I give both of the numbers, that's probably what we'll do. We'll just eat up our nodes. We'll give it both of the numbers, and it'll figure out which one is the minimum number and spit that back. And then here we can store that. Let's see if we have enough. I don't think we have enough room because we have 3 more instructions. What else do we need to do? Okay. We figured out which one's the minimum. We've saved it. That moves down. Move down into the accumulator. Because we've written it down. So the first thing we're going to do is we're going to move up into the accumulator so we can move up, move up, up. So once to subtract, once to store. If we're not saving it, we want to move down to nil so we can read that dummy value. And then I think that's it, really. We just jump back to L. We might have enough. Okay, so that should be minimum done. So let's see. We read in 14. You know what? We're not even handling 0. We're not even handling 0. We do have done. Okay. So we are handling 0. Ignore me. Okay, so we've written 14 down. Actually, we start off with a problem immediately. We need to put... Yeah, we need to put... I don't think I can put on multiple lines. Let's see. Move 999 into accumulator. Save. Yeah, too many operands. That's what I thought. Yeah, I don't think there's a way to do it. Okay, so we're going to have to split the logic up. So this node's going to be a function. It's going to receive 2 inputs, and it's going to determine which one is greater. I really wish if there was just one more register on a node, that would be great. But yeah, anyways. All right, so the first number it gets, we're going to move it into the accumulator, and we're going to save it. We're going to move the right node into the accumulator. We're going to save it. And then we're going to sub right. And so that's going to determine if it's greater than 0, then that means that the right value is less than what we currently have. So we'll do second And then our second label will move right, which of course is too long. So, yeah. Okay. So our second value there. Otherwise, we want to swap and move accumulator right. We want to move right meal because it's going to be pushing that value back because we need one value twice basically because we only have 2 registers, so we have to store our operation and we can store one value. So then we're going to use our memory here, our read write input output, as another memory option or storage location basically. So we've got to clear that out, and then we're going to write the accumulator, which will be the smaller value, which is the first one, and then we're going to jump to our loop label. Okay, so that's our minimum logic, and we can duplicate that for greater than, but we're going to focus on minimum right now. All right, so we read that twice. I don't think we need to read it down twice now. We're just going to move up, down, and then here we're going to move up into the accumulator, and if it's 0, we're going to, same thing we just did earlier, we're going to say we're done. And when we're done, we're going to swap, and we're going to move the accumulator down. And we're going to put our start label there, and that'll be that. And then actually we'll probably want our actual start. We're going to move 999 into accumulator and save it because we're looking for the minimum value. So we're going to start with a maximum value, which is probably going to be wrong if we had a 0 length list, but it doesn't look like we have any 0 length lists coming in, so I don't think that edge case needs to be considered. Okay, let's see, what do we got? We got move accumulator down. Where were we at? Okay, so we moved, we've got our init here, our length. Sorry, my dog is moving in the background. I might need to take a break here and let her out. Let's see, move 999 to the accumulator and save it. Okay, now we start, so we move up into the accumulator. We've got 999 stored here. If it's 0, we're done, so we swap and we write. And if it's not done, this is where we need to find the minimum value. So we're going to swap, move accumulator to the left, move up to the left, move up to the left, because it's going to save the first value. So then we need to write the second value twice, which is going to be move that into the accumulator. And move the accumulator left, move the accumulator left. And then we're going to move left into the accumulator where we will save it. And we'll jump to our loop. Okay, that should do it. That should do it now. So we read in 14. We send 999 and 14. It gave us 14 back. We send it 73. What happened to 14? Okay. So we send 999 over, and then we send, where does 14 go? Fourteen goes in the accumulator. It's not 0, so we swap. We move accumulator left. Shoot. Then we swap. Yeah. So we send 999, then we swap, then we send 14, and we send 14. And we get 14 back, and we write that into our accumulator. We save it. We loop. We got 73. We swap. Actually, I don't even need to swap. I don't need this swap here. Because like that'll write the 14 and then we'll write 999. It doesn't really matter which value I write. It gives me the 14 back. Then I write 73, 14, 14. It gives me 14 back. Then I write 58, 14, 14. It gives me 14 back. And then I write 999. What did we write down? We wrote 14 out. Okay, so that works. Okay, so we need greater than logic over here. So this is we're gonna swap some things up. Once again, I did not copy that. So right, left, hello, left. We're gonna save it, and we're gonna sub our left value. We're gonna move left nil, left, and we're going to left. Okay. The only thing is we want to look for values that are less than 0, because it's different now. So we've got move up, down, and then we do need move accumulator down, move accumulator to the right. Okay. And then we're going to move, this one's going to be basically what we have here. So we're going to move negative 999 to accumulator. We're going to save it. Then we establish our loop. Basically, we just need this code. We've got 2 identical sets of codes. We're just doing them in different orders. So we start with negative 999 because we want greater than. So we always want the number to be less than. And we're not moving up, we're moving left. If we aren't done, we're going to move it to the right. And we're going to move that one to the right. And we're going to move that one to the right. And then we're going to move right into the accumulator. We're going to save it. And then we can just move up, down. Okay, we used a lot of nodes. We used almost all of them. All right, so we've got negative 999. We bring in 14. We check. Ooh, wait, what's going on? I think my order, we write 14. We subtract negative 999. Right? Oh, this one's write negative 999 over. We're writing 14 over. That writes 14 back. Oh, that's right. Okay. Then we write 73 and 14. And that gives me 73 back. Okay. That did it. Okay, 472. Well, the old one was 496, so we're not much better on cycles. We used one less node. Okay. Wow. And instruction count, a whole 20, yeah, 22 instructions less. That's a huge improvement, I gotta say. That is a huge improvement. That's awesome. All right, yeah. Let's see. This let's see. I'm good, damn it, just as good now as I ever was. But nobody want to hire old washed up Randy. Not when all the young folks straight out of school will work a 100-hour week for nothing. And I'm lousy at promoting myself. Always was. Okay. Let's go back to our segment list, and we're moving on to the sequence reverser. Yeah, so this one was 373, 4, and 13. I was kind of competing with myself now. It's kind of a little competition with past me. They always say, like, you only get better, hopefully. Hopefully. Ooh, we got a stack memory node. What is a stack memory node? We've got a book. We got a book that should tell us what a stack memory node. You know what? I should probably turn lights on. It's getting dark in here, isn't it? Did that work? That didn't work. I'll fix that in a minute. Let me find out. You know what? Actually, let's pause the stream here. I shall return. I don't think I have a pause screen. I don't have a pause screen. Can I spin up a pause screen really quick? We'll say pause. We're going to edit OBS on the fly, live. We've got pause here. Everybody's seeing a black screen, hopefully. Hopefully. Do we have text? Text? Yes, text. Paused. Okay. And we'll just say paused. Be back momentarily. Which may be spelt right? Okay, that is huge text. Let's pop you somewhere in there, like center. Can you center? That's centered enough. Okay. Is that actually... I need to go... I'm still new to streaming. Bear with me. I'm going to watch my own stream while on stream. I know you can still hear me while I'm paused. We'll fix that momentarily here. Yeah, it looks like the stream is behind a little bit. Wow, is that not live? That's really not live. It says live, but I'm watching myself still do the last problem. Like really early on in the last problem. Okay. Well. Anyways. I'm going to assume that I'm live right now. Everybody's going to see this eventually, so I'm going to mute myself now on this one.